can go.
All right, so welcome everybody. Today I'm going to be starting the new series of relational theory and database design. It's a series that we intend to convey essentially the original ideas that were lost in time with the relational model and relational theory. And today I'm going to talk almost exclusively about the history and where we are. So do a self-assessment of the industry. Maybe that's not a self-assessment, but an assessment of the industry and its current state and how we ended up on the state that we are. So let's go here. So there's other steps here, but this will be the subsequent talks. Basically, the way this will work is that I'll just open the stuff, talk about it, uh, and I intend to make it an interactive way. So if anybody's interested to raise their voice and ask any question or make any comment, feel welcome. I prefer to have that at the time of the topic, otherwise we just lose track of it. All right, so let's start talking about what relational theory actually is. So, and what is it? What is the impact that we have with not conforming with it or not knowing how to implement it in the first place? So, uh, I'm a student from Fabian Pascal. He doesn't like to be called a professor, but I think he is. Uh, and he's one of those people that have exclusively dedicated his career to debunk and debate people in the database matters. So he's been doing that since the late 80s. He's friends with David McGovern, which is another personality of the circle, uh, alongside other people like CJ Date, which is who is a phenomenal professor and very well known person. Okay, so with that, let's go over here. So essentially, the story of it starts all the way back in the late 70s. I think if we stretch a little bit, the 60s when we were talking about data management. So back in the day, people had a huge issue on storing information. So computers were getting more and more efficient at doing their own tasks. People were excited about the possibility of storing information and loading them back because you can just leave a computer on all the time. You need to persist information, you need to store it in memory. So different storage techniques came and went. Uh, Punch cards, you can say it's a form of storage, right? But there's other methods as well, like tape. So tape, using magnetic tapes. Man, why is that such a hard word? Uh, but using magnetic tapes at the time was starting to become very cheap. It's still used today, by the way. Like a lot of storage goes like gets archived and goes to magnetic tapes because it's very cheap, right? And it stores like petabytes of data. So they're still around. And then there was this major problem at the time of the systems that they were very brittle. So what I'm talking about is if you think of the architectures of the computers, there was all sorts of computers doing all sorts of things with different architectures. Different programming languages were getting popular, and so were storage techniques. So if I plainly write bytes to the disk, um, I can look at this file here. Let me open another buffer. So, oops. So let me do this. Actually, let's do this. So scratch. There's some text here, right? So there's some text on Emacs. If I change to Hexel mode, yes, sir. There we go. Those are the bytes of a buffer, right, in Emacs. So, of course, we can literally, it's legible, right, because we can just convert this to ASCII and see the contents. But it's not so simple when you are making a complicated data structure to be written in the disk, right? We're talking about an age where you had very few standards, if not none. And people were concerned because legitimately so, because they couldn't store and retrieve that information uh, in a way that doesn't that isolates them from the complexities of the hardware. And that's the main problem that I think was fluctuating over the times. Um, so basically, imagine if you were programming like C, let's say, and then you store I don't know, some C struct in the disk. Now, if you try to load that in a higher level language, like I don't know, some language that has garbage collection and like OCaml. So a struct in OCaml, a record in OCaml, a struct might, I'm not sure about that, but a record in OCaml will have other stuff, right, and other things that are not really necessarily mapping one to one with what was written. So just reading that data back required you to make a very specialized mechanism to retrieve such information. And then after you retrieve such information, let's suppose that I get this buffer here. So I get this segment here. So I go from here to here. Now, cool, I got this segment of data. Now I need to learn what to do with it. And that's a whole nother beast, right? I need to how to make this information useful. It's just a random segment of bytes. So that's a nightmare. I think everyone can see that. So that's basically the state of the industry back in the 60s and 70s. And then some proposals came down during that time. But I want to start from a different angle, looking at making a critique of what was going on and what happened and what is the aftermath of it. So I wrote down here, so the absence of a true relational database management system. So that is the thesis of Pascal. He believes that there are no relational database management systems around today that actually implement EF-COD's relational model, data model, the RDM. So he believes that there is a fundamental misconception in the industry, and it's a combination of different factors and market control, dominance, he puts in that way, um, educational confusion, and other historical accidents, like COD made a few of them, for example. So a bunch of historical accidents that led us to the state of affairs that we are now. So that's the main thesis that we are going to go with here. Does anybody want to say anything before I dive deeper?
I'm just gonna say that
Mm-hmm.
we do not have a true relational system yet.
That might happen. That might happen soon. All right. So for those not aware, we're making one. So anyway, so relational model is essentially at its inception an applied theory. So when we are talking about an applied theory, it's very different from an actual theoretical from a theory, right? So if you think of like mathematics, well, mathematics in itself is often not very useful. We need to apply it somehow to the world so we can see its effects. And it takes an ontological commitment to mathematics and its representation of reality. So you can represent that formalism that you just proposed in the world. So when you, for example, discover a theorem like the Pythagorean triangle theorem, so you make up the theorem, you prove it, cool. So it's true, but how do I apply that theorem in reality? What can I use it for? So those are questions that you have to commit yourself to answer before you formulate an applied theory. And at times, that formalism will actually not really exist. For example, for those, I think we entered on discussions here of whether or not um, real numbers exist, right? I personally don't think they are instantiatable in reality, and they are a good example because you can never arbitrarily just split things ad infinitum in reality, right? You need to measure things up to a degree. So the degree may be arbitrary, but that doesn't prove infinity. So anyway, there's different commitments you need to make with parts of the formalism so you can actually apply it to reality. So it's not just simply apply it with a theoretical knowledge. You need to make some adjustments to reality sometimes. For example, another good example are floats, right? Floats, they are actually not continuum. Uh, that is, the cardinality of the float set that we have in programming languages, it's not continuum. They're not infinite. They're very large, but that's not infinity, right? So we basically, when we are talking about the CODS relational data model, we're not talking about the tabular storage technique. I've heard things like, oh, relational databases are about storing square data. Like, I don't even know what square data is. It's first, I think it's a misnomer, right? There is no such thing as a shape in data. There's a shape in encoded data. That's a different thing. And the relational data model is not about tables either. So I think there's two misconceptions here. But where do they come from? So we're talking about mathematical relation theory. So the idea of managing sets with uh, basically sets with a meaning criteria. So you would have a relation isn't like you can think of a relation as an operator. So imagine less than. Well, less than enforces a meaning criteria for a domain, right? So you can apply that on integers, let's say, and then you have properties with it, like ordering and so on. But a relation is essentially enforcing a meaning criteria for entrance on a set, right? So these members, like if it's less than, then the tuple for one does not enter on the set less than, right? On the relation less than. It's not part of that relation because it violates the constraint. So that's the first. And then simple set theory, which is essentially uh, encoded in first order predicate logic. So this is when we are talking about no higher order predicates. And that is very relevant if we're not concerned with, if we're concerned about not entering paradoxes and building non-haltable uh, uh, properties, right? So the things are decidable and they compute and computable. So not Turing complete, another way to put it. So simple set theory is essentially just manipulating sets instead of higher operations with higher order sets, right? So you just have intersection, union, and very simple stuff. And then, of course, you have the equivalents of those things in first order predicate logic. Like, for example, intersection and union could be and or, right? So you have analogous of those operations with members of such sets. So the RDM, it basically tried to provide three components. First is the formal data structure. So notice, this is nothing to do with how the data gets stored in the disk. When I say data structure, I mean how to organize logically the facts that you have in the world. And relations, using relations as sets of tuples over domains is a good way to do it because you essentially analyze anything in the world and then you can compose a very simple object out of that and then manipulate that as a part of a set, right? As an element of a set. We need formal algebra, so basically to gather inference out of it, so to query. We need to have something that actually can make calculations on top of the data and manipulate it algebraically. And then we need a formal semantics, because if you just have random tuples and an algebra, you can't really make sure that that conforms with the conceptual model that you are modeling your data on top of. So constraints, they are immensely necessary. I would say even mandatory for your data to actually make sense and be coherent with the outer world. So, and then in that case, a relational database is a logical model of a conceptual model and correctness of inference is guaranteed only by fidelity to that formal system. So I think a good way to see it is think about this. We have like the real world in like the planet, right? So we have planet Earth, okay, and then you have a theory like cartology and geography, right? So you have like studies of the landscape, and etc. Like rocks, tectonic theory, and so on. So you have different formalisms. You have different bodies of science attempting to study a specific object, right? Instead of just being broad. Uh, and then atop of cartography, which you could say it's a branch of geology or study of geography. Um, I said geology, sorry, I meant geography, right? So it's a branch, you can say it's a branch of geography. Cool. And then on top of cartography, you have the task to design a map. And then you have the formal representation of a map and the whole theory with the map. And then you have physically the map that you built, right? So you have a scale, you have the drawings of the shoreline and so on. So you have the the labels and what have you. So the analogy here is very similar because the conceptual model is what's giving you the meaning criteria for you to understand uh, what part of the world you're interested in. So it's crucial for you to get that correct and express that in the map itself. Now, how you encode physically the map is a different story. And those parts, those steps, they are more or less independent, but they still need to be coordinated based on such a conceptual model. So the conceptual model here is the thing that we want to keep in throughout the whole process, but by encoding with a formal theory. So the formal theory, so the conceptual model is I want to model uh, this part of the world with a formal theory X, um, with such a logical schema and physically implementing this matter. So it's multiple layers of abstraction that we are talking about here. Okay, so the industry never learned theory.
Mageta,
So yeah, go.
I have a question. Um, well, I have a comment and a question. So I think that the separation that you proposed in the last section, which was
Mm-hmm.
that we're not talking about tables, we're not talking about how to are we gonna store that. To me, that
Mm-hmm.
relates really close to what, well, the idea of having a language specification. So you
I
may
agree.
have SML New Journey and you may also have Melton, but they are both
Mm-hmm.
instantiations of a particular unique specification.
Yeah,
And we are talking about the specification in this case because I think, and that's very important, I think to mention that a lot of engineers think that an implementation of a specification is the thing that we are talking about, but it isn't. We're not
yeah.
talking about any instance of it.
Yes, exactly. So it's like for example, if you think of bubble sort, for example, so you can blame bubble sort for being slow, right? Because if you look at its asymptote, like you can make a calculation, like you can analyze how the algorithm performs, right, without a computer, and you can understand that it's bad in a von Neumann machine
Yeah,
executing it, right?
yeah,
But if you change the architecture, that you cannot take that assumption anymore. So if you make a parallel, like a concurrent bubble sort, then the complexity of it drops to like I think on, right, from on squared. So you change the architecture, the execution of it uh, can be changed as well, and then you just now have a different computational model. That's just a silly example, but I think it echoes the sentiment that we are not talking about the physical level. Man, you can do all sorts of things in the physical layer, right? And that's
yeah,
part of why I don't like to criticize too much the current vendors. Like Pascal does, I don't like to do that because I think it's counterproductive, right? I
Well,
think they miss a lot of things, but
but
they try
there's
to
a
do whatever
problem.
is possible.
No,
Yeah, go.
they try to do whatever is possible, and that's fair. But you are by not criticizing it, you're not criticizing they are misnaming their stuff. I think that
True.
if
That is true.
Pascal's critique would disappear if they stopped calling their stuff what they do currently
You know
call.
what's funny? The SQL standard doesn't mention being relational.
Exactly.
Like
So
the
that
word
makes
is
it
not
even
there.
worse. That makes it
Yes.
even worse. That people are using the wrong words.
Yeah,
And
here.
then when you say that to people that hey you should use the proper words to describe things, then
Mhm.
they think we're being pedantic for the sake of being pedantic of being assholes. But
Yeah.
the reason that this matters is because if you misnomer something a good enough amount of times, the lie starts to be understood as the truth.
Yeah. I agree.
So that's
So
just my comment about that. My question is about the last paragraph
mhm,
there about having the layers of abstraction. So the conceptual
okay.
model is a portion of the world that we want to represent,
Yes,
and the
that's a good
logical
way to
model
put it.
is an encoding, is a of how we're going to describe it.
It's an application. It's an encoding of an applied theory, right? So in the map analogy, so you would have I want to make it would be a set. The conceptual model here would be like a set of in natural language
Mhm.
of the constraints that you want to convey.
Mhm.
So I want the map of I don't know. I want the map of China with a fidelity of I don't know. Uh, the scale of maps. So
Yeah.
with
Yeah.
this scale,
Yeah.
with a bunch of requirements that you may put in there, I want all the cities showing up, and I want the railway map of China overlaid atop of it. So
And I want the north to be up. That's also something you shouldn't forget.
okay. Thank you, Maria. So that's very important.
That's fair enough.
And then you have the theory, right? A formal theory for you to encode that, which is cartography, and then you have techniques, right, on top of cartography, to encode using like scale, using uh, like Mercator projection, right? That's a way to
Mhm.
to
Mhm.
encode a map.
Yeah.
So you use all of this applied theory, which borrow from a plethora of other things, right? So you're going to use mathematics, whatever,
Yeah.
and then you convey those things in a encoded format, which is the rules to compose a map, and only then you compose an actual physical map,
Yeah.
right?
Yeah, that's
So
that analogy makes perfect sense. What I also think
now,
it's important to say is to justify, because for all of us here it's probably obvious, but I think for the recording purposes we should just plainly state it. Why this is not just intellectual masturbation? Like why should people care about it? The reason they should care about it is because the so-called masturbation give you guarantees, and that's what we are
exactly.
looking for.
Man, I get there's multiple things I can go over here of that make me angry. Like for example, people mention all the time in agile, right? They come up with the uh, waterfall,
Hmm.
and then I was thinking, man, like it's silly to believe that that thing ever existed.
Yeah,
Because for
I
example,
thought the
this
same
this
back in the
case here,
day.
this case here, right? It's a huge strawman of something that never existed. So like the fact that some people might have done that, it's another topic, right? That might happen. Like people do crazy things all the time,
Yeah,
but like to think that that was an institutionalized and well accepted theory
practice.
is insane. Practice is insane.
Yeah,
Like for example here, like it's not that this is a process that you go and you basically like it gives the impression that you need to gather all the information first and then go to the next step and then go to the next step and so on, right? And you can't go back. But in reality, that's think about this. If you reach here, the physical layer, and you notice that you encoded something wrong, you need maybe and then that's like a fundamental misunderstanding of a business rule. You need to go back and change everything, right? The conceptual model. You need to adjust it.
yeah,
But it's an iterative process that you go over a feedback loop. So isn't this the same thing that people were talking about agile development? It is, you
Yeah,
see.
yeah, this
So
happens all the time.
this is a case, just a silly way for me to represent that, to convey, I would say, that the theory is like you can't just expect to come up with things. Like you can probably just be successful without doing things based on theory, right? That might work, but you don't have control over it, and I don't understand why would you just rescind
Yeah,
control over something if you have the option.
yeah, and we
Uh,
should also emphasize that if the theory is getting on your way of applying on practice, that's a problem of the implementation of it. So the reason that
yeah.
applying all of this theory in SQL sucks is a problem of SQL, not of the theory.
So and then you should. Okay, I have a thing that I was going to keep for the next.
You can do that, keep on the next, but it's important to justify because when you start talking about theories for engineers, a lot of them just go, "Man, this is fun, like this is cool," but
Like
all these
I'll give
nerdy
you
things,
one
these are not
example
in
of
real
this.
world practice. This is just
I'll give you one
intellectual
example.
masturbation.
So people come like I don't think people understand normalization, right?
Yeah,
Normalization as a procedure is silly. Like a first normal form, second normal form. It's not a procedure to fix repair relations. Um, the the thing that is insane is like when you think of denormalization versus normalization, right? And then how can a theory be evaluated by performance if you think about it? And then I was thinking about that, and man, it's not that people are incorrect. If you do things like everything in six normal form and you have 100 tables to join, and you don't you miss some index here and there, it's going to be faster for you to just retrieve smaller information in a single table, right? That might be the case. That of course that's bound by the vendor. That depends on
yeah,
multiple variables, but that might be. But then the fact that it might be the case for a specific vendor says absolutely nothing about how the theory is organized because it's not a physical model, right? It's how it was encoded on that vendor. So anyway, that's just
yeah.
a
Yeah,
example.
but I just wanted to open this tangent because people may immediately say, okay, I should not care about this because this is just a nerd saying that theory matters, but I know it doesn't matter. We are
Yeah.
telling you on, straight on that this matters because if you follow the theory, you're going to gain something. And that's like, if you're just an utilitarian person, just listen. You're going to gain something, and by not using, you're losing something. You should be aware of what you're trading. That's my point.
I
If you
agree.
shouldn't bother with the theory, why do you learn mathematics at all?
But that's another
Exactly.
rant. People think that you shouldn't.
Yes, you shouldn't. You should just learn the applied mathematics, right?
Like
That's the
that's a completely separate rant, but that's essentially what people think. Oh, you don't have to listen to those nerds saying that you need to learn math to do programming. You can have a job in a very big company without knowing any math. They actually do marketing of like YouTube videos on top of that. And
and
that's
I think I saw long time ago. Let me just look at here.
be
So
careful what you're sharing right now because this is being
eh,
recorded.
why no monads on closure?
So
Like
the
I
thing,
read,
hmm
yeah, something like this, right? I read this article here, and I couldn't help but think like the guy basically goes over like a rant of why he doesn't like to like people incorporating uh like a like category theory and some stuff. I don't remember exactly the
yeah.
the details he goes over,
What
but I
a
think he kind
contrast.
of
The video that
yeah.
Marinho shared about Rust not following theory explicitly mentions category theory as an example of like performance analysis. It's crazy. Anyway, rant,
And
tangent
you know
closed.
what's funny about the monads thing? Just to bring that up again, like people use that all the time, right? So why would you not want to know what you're using? I always find that curious
It's because of
because
the name, man. We should have called it interface.
by the way, this
That's what
was
I'm
the
saying.
same. This was the main critique for SQL back in the day. Like I think if you read this article here from Pascal, jargon. Like, read this quote here. The relational model was simple and elegant and powerful, but Cod presented his concepts with a lot of mathematical jargon. He's basically a mathematician. And the first time we read his paper, it wasn't really obvious how elegant and simple this concept was. He took a simple concept and made it complicated. The other problem was that it wasn't clear at first whether these ideas could be efficiently implemented with a program that would be have adequate performance. Chamberlain is one of the guys
Yeah,
that
the
implemented
second
SQL.
concern about can we make this implementation fast? That's a valid concern. But
That's
the
a
other
valid one.
question is
Yes.
like, how do you know this is not a skill issue on your part?
Exactly, which I think was. Man, I read the. Okay, it's funny because the guy's like an IBM, very qualified
Yeah, I'm
personnel,
not
right?
saying he wasn't. I'm just saying that you should have, if you're
Yeah,
a
yeah.
non
You should have
intellectually
at
honest
least
person,
you should at least do a self assessment, right?
self-check exactly. You should
Yes.
check yourself like, okay, is this bullshit or is this on me? I'm not
Indeed.
saying it wasn't bullshit. It may have
I
been
think it
bullshit.
was. I think it was.
Can you cough?
The paper. I think it was because if you read the first paper, maybe it's just an anachronism, right? Because looking now, it's easy to see how that was supposed to be materialized, right? Uh,
Yeah, like
when you're
you are
talking
not
about,
an IBM supermaster, but you got it.
I'm talking about the time, right? Because I'm trying to understand, like, from the perspective of somebody at the time. Because what is a database for these people at the time? It's like IMS from IBM, like IMS, IBM. It's like stuff like these. Let me go here.
Yeah, but if you are assessing seriously a piece of potentially innovative work, you need to get loose on your preconceptions. If they thought IMS was a database, fine. But if this guy came in and is proposing that it's something else, you cannot judge it properly by doing a simple comparison.
I think there's an image here. Yeah, databases for these people were basically graphs, right? Which is an attempt to already. Okay, I'm going ahead of myself. Let me go back here.
Yeah.
So I'm gonna go over that.
Okay, anyway, tangent aside, you should listen to what Magetta is explaining. Not because you may not like Magetta, but you need to listen to the trade offs that you're about to do when you drop theory. That's that's the only thing I wanted to point out.
You should. That's the definition of being free, right? Knowing what you're
Exactly.
taking a trade off.
Exactly. But that's very profound. People will not understand that, but I do understand because
Well,
I think that's on the we should meet you, right?
so anyway, like back to the
Yeah.
thing here. Uh, so essentially, we've been talking about this. So the industry never really implemented the RDM properly. So people came up with implementations of things, but not really the a theoretically compliant theory. So SQL basically was a disaster since the beginning. By the way, funny enough, I think I already mentioned the story, but off camera. The When IBM dropped SQL, uh, that was they released a paper, right? And then Larry Ellison, the Oracle guy, he read that paper and he immediately started work on it. And then legend goes that he was one of the few people included, and we're talking about Professor Wong and Stonebreaker from Berkeley. At the time, they were the people that were like basically looking at the thing. Like they read the paper and said, "Man, this is trash. Like this is not really." Because what is IBM doing? Like I talked about the IMS, right? And then IBM had this thing here called PL1 or PLY, I suppose. It changed the language. There we go. So IBM had this thing called PLI, so Programming Language One. That's a very creative name for a language, right? Um, and then it's also spelled with an actual one. So it was basically a procedural language that looks like this. Does it look like something?
It looks like a COBOL and SQL also.
Yeah, it reminded
IBM
me of
only
SQL.
thinks that way because they are a company that we're concerned primarily. We're talking like I don't know about IBM today. Okay, I don't. I would be surprised if it's any different. But we're talking about the company that has basically a monopoly over the mainframe market in the US. So they basically own the entire market themselves. And so they could do anything they wanted, right? They have customers, like basically everybody is their customer somehow. So their product is widespread. So they set the standards. Microsoft, for example, only could get popular like Windows because they paired with IBM, right? IBM literally sold Bill Gates the the PC standard because people don't interact with hardware, right? They interact with software. And IBM was one of these companies that never understood that. They kept on the hardware business, trying, but that doesn't mean that they didn't set standards because of the hardware, right? So this approach of doing everything based on COBOL essentially came from here. So Code as You was an initiative. So it was a conference committee on data systems language. So it was a consortium, that's what they call it. They basically they got COBOL out of it, and they were literally shoving COBOL everywhere they could. So SQL is a historical accident of a company that was basically heavily invested on COBOL. So that's just a tangent here. But anyway, so you can see a lot of this impetus right at the time to just shove whatever IBM already had and incorporate company practices in the theory. You see, so it's not merely the fact that they didn't understand that too, but the fact that the company has an overwhelming weight uh, on the implementation that they will provide. So does that make sense? Like I can give one example with like Meta, for example.
Yeah,
So
they were
Meta does,
biased. Oh, sorry.
yeah, bias.
They
Thank you.
were
That's
biased
the
not
one.
only because they didn't understand what's the theory, but they were also biased because they wanted to shove whatever would look COBOL-ish into it.
Basically, that's my
Yeah.
guess.
Okay, so
So
why does this matter? Because they got the semantics wrong, but now they also
mhm.
got the syntax wrong.
Man, here's a interesting parallel. Google is very like that. Like if you look at what like the languages that came out of Google, like languages and tools, right? That came out of Google and compare them to Facebook/Meta, it's like night and day. Like Meta came up with good stuff. Like React, it's like okay, it's a top of a good architecture, right? It's basically they copy down, and but that's good. They came up with Reason, right? Reason or Rescript, I don't remember which came from them. Uh, but they're like good languages, right? Good tools, that is. They have good abstractions on top of them. Google, on the other hand, they got onto devices of the corporation. So what do they provide? Well, they came up with proto buffers, like protocol buffers, which essentially is a encoding format that looks like C data structures. Heavily byte oriented, like very low level, for no reason. XML binary I, already exists for that reason and existed for a long time. Uh, so there's no isolation there, right, from the physical to the logical and portal. But there's also like other things that Google did, like Go, like from Rob Pike. I don't want to trash on Rob Pike because I kind of like him somehow. But well, the Plan 9 initiative and like the whole thing with like Rob Pike, it's basically a testament to that, right? To that commitment to Google, to this C-like as well. Google is like a Java C++ company, right? It's like Microsoft. It's a huge C++ place. People think of Microsoft as C sharp, but it's actually C++, right? It was. I don't know about now. Anyway, so these vices, the corporate vices, they also get embedded on their implementation, right? So we have a bunch of these. Anyway, let's go here.
Yeah, and I also
So
should mention that these vices are not like, how should I say? They are different from vices that are actually based on a rational argument. So like if you ask Marinho, every programming language development should include tail calls. But it's not because Marinho doesn't have a rational explanation on why you should do it. That's the difference. Because you may say that it's a vice, but that's wrong nomenclature. That should also be like a foundation that is based on arguments. It's different in a vice where you cannot really justify it aside from familiarity. So you're doing Go like C because everybody is used to C. That's a
Hmm.
different argument than saying C is good, hence we should inspire ourselves in it. People can be familiar with bad things.
I think comparing Zig to Go here is very pertinent because Zig was like, okay, yeah, C is actually pretty decent. There are some issues with it. We should work on them. So let's make a new language. But fundamentally, there are some good ideas there. We should keep them. That's the Zig position, right?
Yeah, and I have the impression that the Go position is like we will keep most of it, and I don't see the same level of questioning that I think we should be seeing from them.
Well, from what I understand, the original idea behind Go was to basically provide, like, give you guarantees by not giving you things, right? So there's only one way to do something, and it's dumb the way that you, like, by intent, by design, it should be dumb for you to do anything. Uh, but then you won't end up with a very arcane uh, standard like C++ did, right? I think that's the idea. So basically, treat programmers as dumb and give them little control. I mean, by giving them little. So you work by guarantees, right? That what I'm trying to say is this: you work by having guarantees. So why people prefer like Python is that it gives you some guarantees that C doesn't, right? It will basically run a you declare a list and you don't need to worry about memory, right? That's one guarantee. It lacks in other guarantees that ML gives you, right? Like type mainly, uh, but also like scope and all of this other stuff, right? I think Go tries to go at the same direction, but instead by limiting what it gives you. So you already know the guarantees that Go will give you, but they're very limited, which I
Yeah,
think
but
is fair.
yeah, but
I
there's also a fair argument to say that by giving you less power, we are giving you more guarantees. That's the whole point of constraints, right? We are
Yeah.
disallowing you of doing things on purpose because we know that the chances of you not being smart enough and shooting yourself in the foot are high. So yes, we won't allow you to do a let open in the top level. We won't allow you to put a new one on the table on purpose because we know you're going to be tempted on doing those things. So we're not going
Hmm.
to allow you to do that.
I get tempted to put nulls everywhere, but I know that that's a problem, right?
Yeah, exactly. No,
Oh
some
yeah.
people, the people that are usually very knowledgeable, they are capable of, they have the discipline for themselves. So even if you have the option, you don't do it. But
Hmm.
what is the best way to guarantee people won't do it? By not allowing you to do it. So I think there is an argument there of like, oh, we are assuming you were dumb as a programmer. I like the idea as a concept. We just have to discuss what are we going to be restricting you in this case.
Yeah,
Because if you
makes
go all the
sense.
way to Go, you're going to be restricting all the way to like you have a single primitive in the language to do everything. That's one
By the
way to
way,
go about it.
Harper has a good quote, Robert Harper, that he made on a talk. I think it was a lesson actually. I saw on YouTube, and then he says something like, uh, "The power of expression doesn't come from its from." He's talking about programming languages, right?
Hmm.
From a type system angle, it doesn't come from its affordances, but from its strictures, right? So
Yeah,
constraints
yeah,
essentially.
exactly.
I think
So
that's very well
I
said.
think the argument by itself can be a good thing because, for example, C++ languages. That's why Commander loves C++ because he likes the power, the full power that he has. And the same goes with Common Lisp, I believe. You can do very potentially dangerous stuff, but if you are smart enough, you can actually make some productive things out of that power. The assumption that you are smart enough is the problem. I'm not saying he is or he's not. I'm just saying that to me, the argument that he's proposing is I like having all the power, and I don't trust myself having all of that.
I
Imagine
wouldn't.
somebody else.
Yeah, yeah, I don't as well. I don't trust myself to do things in like that.
Anyway, let's
Okay,
continue.
so let's continue here. So anyway, so IBM at the time they started working on a project called System R, which if you ask me, it's a very good name for a project. So basically, it was implementation of the RDM, trying to go with the practicality of the idea, right? So there is talk, and that's from Pascal, that they were trying to actually do the opposite. If you think of IBM's market dominance, they didn't really want another competitor for the IMS, right? So this experiment was basically to disprove the idea. But anyway, that's just a talk. But the idea is that it was a practical example, right? An experiment. So people were just trying to get a hold of the idea first. And then there were some problems that came up with it. Is that, namely, SQL is not a true relational data sublanguage, which is one of the things that Cod expressed on his paper with Alpha. So Cod at the time, he was working on his own language. It was called Alpha. That was going to be like an actual embedded data sublanguage, like the kind of what's the name of the datomic one?
Data log.
Data log, yes, kind of like a data log tries to be, right? An embedded data sublanguage that works exclusively with the relational context. It mixes declarative fragments with procedural structure. It avoids explicit relational operators because they were too mathematical. Like that's an actual complaint on the quote that I read, right? You can see that of the mathematical jargon. So people are not interested on saying like pi as an operation, right? They were concerned with like, okay, let's use or a union or things from set theory, right? They were more concerned of like join, select, and things like that. So nested queries, they introduce procedural redundancy. I will go over examples so we can go over that. And other additions, like subsequent additions to SQL by the standard or not, they basically have explicit operators that basically made the whole thing more fragile. So Cod at the time, he basically hated the implementation. And here's an interesting piece of history. And I think I started to mention it, but I didn't finish. It seems like it. I am not going to make any accusations here, but it seems like Larry Ellison, he was one of the people, alongside the Berkeley people, that understood that SQL was really bad because Cod voiced that out. Like he made it very clear that what they were doing was garbage. So, not in those words, I guess, but he did say that it was not good. It was not what he intended. So CJ Date basically is one of these people that mentioned that, but the designers didn't know what they were doing. But the interesting bit is the Larry Ellison. He's one of the people that did know that it was bad, but he's the first guy that implemented a materialized version of a SQL DBMS. So he basically came up with Oracle, right? He already had a contract with. He had previously a contract with with the CIA, and then he pulled off a database and sold to the CIA a very rudimentary version that had very simple joins. Very, I think I have a link somewhere here, but he pulled off like something using SQL, and then he already got clients and he started selling that. When IBM noticed that they were losing market to this new rising thing, at the time you had Oracle and Ingress, right? Both of them. Ingress was from Berkeley, from Stonebreaker and Wong. So they were selling like for multiple. Like Ingress was open source, by the way. So basically, just had to pay for the tape of the source code, and then you got the tape, and then you install it. So when IBM noticed that they were losing segments of the market to this new thing, they rushed SystemR out of the market and then released it with SQL. And the only other platform that was using SQL was Oracle. So then basically Oracle was, got so much market share because it became a standard, right? IBM was with DB2, it was supporting SQL. So that's a tragedy on its own, but let's continue. All right, so alternatives at the time existed. So Quell, it's funny because it's SQL, Quell, right? But anyway, Quell was an Ingress version. So Ingress stands for Information Graphics Retrieval, and I don't remember what the DES means, but something like that. It was a database that Stonebreaker and Wong were working with at the time, and it was like, among other things, it was genuinely declarative. It had no nested queries, and it was designed by people who actually understood what they were doing. But then, since we are in the worse is better world, then IBM basically rushed that thing to the market because they were losing things with Oracle's speedrun. And then when they released DB2, it was over, right? Nobody wanted to do anything anymore with anything else. I have a link here. I'll just open it up. But it's just to show the state that Oracle V2, which was the first release, mind you, there was no Oracle V1 because they considered it was bad. Um, yeah, here. So Larry Ellison founded blah blah. So it was the first commercially available relational database system. The version did not support transactions, but implemented basic SQL functionality of queries and joins. Larry Ellison developed a relational database system that based on Codd's paper. Although IBM had a prototype of a relational database, System R, IBM didn't really believe in its success. So, but Ellison believed in the relational idea. So basically, the guy understood that it was going to be a next big thing. He got a niche of the market. He rushed a product very early, and then he got contracts, and that's it. It was cemented because later on, IBM noticed that they were losing market share right there with their product. That's very funny. There's this quote here. It's from an interview. So Stormbreaker said an implementation of Quell in Ingress was substantially better than Oracle's adoption of SQL. Stonebreaker said Oracle had a head start and was achieving strong growth using sales tactics I would not condone. And the times never change, do they? However, he said that Ingress might have overtaken Oracle in 85, were it not for an intervention by IBM. In late 83, Big Blue, so that is IBM, introduced DB2, which by the way, I think today is still the best database out there in terms of performance and feature. Which, although not its first commercial relational database, was soon to become the flagship of a new vanguard. DB2 used SQL, and with IBM's dominance over the mainframe market, it was game over for rival languages, whether they were technically superior or not. But for Chamberlain, it was the approval of the national and then international standard bodies and the adoption by the US government purchasing authorities, which helped win the day for SQL. So that's a very tragic piece of history for you guys. Okay, let's go. I'm almost ending. I'm not sure how we are with time. Okay, so I'll try to be quick. So, okay. So, basically, with that, we ended up with a standardization of SQL, right? And it is essentially an inverted process because when we were talking about SQL, we were talking about vendors that implemented incompatible dialects at first, and then those vendors later codified then into a standard. So the industry, like each one of the, like Oracle has their own version of SQL, right? IBM had their own version, and then they were basically trying to incorporate the same version later on, right? So you have incompatible dialects up to a point. It's kind of very similar with Lisp, right? Except that Lisp actually has good semantics. So people could actually pull off like Common Lisp with a, even if it ended up with a bloated standard, right? Full of stuff. But they did. So the ANSI and the ISO, ANSI is the American, right, standard, and ISO is the international one in Switzerland. They have SQL committees that were basically dominated by practitioners and vendors. without any grounding on the RDM, which makes total sense, right? If I have a big product and I run my product on this thing, I will want some chairs on the standardization of this trash because I want to not have to do work and dictate the rules, right, on my favor. So basically, what happened is that the word relational was excluded, right? So the standard isn't even mentioned. It primary keys were made optional. Nulls were institutionalized. By the way, non-relational features accumulated uh, without constraint. Uh, Nulls is one of them, but there's many others, right? Like for example, the fact that you can produce duplicates, like non-unique, is one of them. So any other industry trash and vice that was conveniently added over the years, like a bunch of features that were popular at the time. Like right now, for example, AI is popular, right? And people are talking about encoding formats in AI, and people are talking about Toon, right? So it was as if they just looked, okay, Toon is popular. Let's encode Toon on the standard. There we go. You have Toon now. So it was basically an ad hoc process, right? And then I'll just go over these so I can give the examples that I promised from here. But I'll just go over the rest pretty quick. So anyway, so
Uh,
they
real
ratified.
quick, real quick before I move
Yeah.
on, they did add JSON to the SQL standard, no? Who's to say
Yes.
they won't actually add Toon later?
Yeah. Exactly my point. Yes. I mean, if it gets popular enough, they might, right? So here's the sad part. SQL was supposed resilience. It's not because of sound design, but because of unchecked accretion. So the fact that we added like object-oriented features, man, like people don't realize this, but if you go to Postgres and you look and if you search for like object-oriented Postgres, that was a thing back in the day. People were really betting on this craze back in the 90s, right? On the dot-com bubble, Java was taking over. Everything needed to be object-oriented, and databases need to be object-oriented. Why not, right? So just add object-oriented stuff on it as well. Today, if you go and look at the features, people actually recommend not even using it. I think there's a massive list of don't use this on Postgres, right? XML is another one of them. As much as I like XML, there's a bunch of trash that got added because it became popular at the time and people wanted it to be a standard. So XPath and all this stuff got added as well. Graph stuff, Postgres, I don't think it has graph. I think you can encode a graph, but it doesn't have graph features
Yeah, we should
by
mention
default.
explicitly, if you want to make a graph in Postgres, please watch Jean's talk.
Oh yeah, he has made one. But I think others do. So I think SQL Server does have graph structures implemented on it by default. Oracle as well, I think. So anyway, like these things are just opportunistically added later, right? They're not really like they don't have anything to do with the relational model. Man, like you can implement all these things with the relational model. Like subtyping, you can implement with the relational model. So you don't need like an object-oriented feature for that. You can implement XML with relations. You can implement JSON with relations. Heck, JSON is simpler than XML. And you can implement graphs with just man, you can implement graph with tables. So you can implement with relations, right? And anyway, so they didn't care if those things are not violated or not relational principles, but they were basically there for to try to uh, create some. So basically, think about this: I have my own product. I did this feature. I want it on a standard because now my competitors are lagging behind. You see, so I can claim I'm compliant with the standard, so it doesn't matter. Anyway, and then here's the theory. I do think he's true. He's right when he says this to some extent. So, and that's from Pascal. So SQL came to be thought in terms of its syntax, right? And it's part of the disagreement between Pascal and CJ Date because he claims Date is a language person, right? Which I think is a fair critique. But anyway, like we think of SQL not with its relational background because it does have a relational engine on top of it. But we think of the syntax like select from blah 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 and a clause, right? And that has huge problems when we are thinking of the actual semantics of something. Like I saw projects like, for example, what was that thing? Prequel. This thing here. Is that it? Nope, that's PHP stuff. Laravel. SQL. Uh, man, prequel. Oh, these. This is from Google, I think. No, I'm not sure if this is the one. No, no. Oh, yes, I think. Not really.
Is
I
that
mean,
the
this
thing where
works.
they wanted to add pipes to SQL?
Yes, that thing. Do you have the link? Prequel. Is this?
No, I think
Yeah,
it was that one actually.
yeah.
Oh,
Okay,
did they
but
change
I do
this a
have a
little?
hot take though. If you're gonna use SQL anyway, I prefer it with types than without it. I would replace SQL, but if I am obligated to use
Well,
it, I would put
here's the
pipes
thing.
on it.
SQL is typed. PL,
I don't know.
like the languages that use it, they have silly types because they're handling the procedural body as a string, right? That's silly. But SQL itself is typed.
Well, not statically, but yes.
Well, it is statically. The query does not run.
Exactly. Only at the time of running it, it will blow up.
No, but that's the static, right?
No, 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 no. I want when it loads the SQL file, I want it already to blow up.
Oh,
I
but it
don't want
does.
it. No,
But
in
man,
my
When?
here's the thing.
experience, I couldn't make that happen.
SQL does. PL PGSQL doesn't.
Oh, okay.
May
So maybe
may
that was my
not.
problem. I think I was in PL's SQL.
Yeah, if it was PL PGSQL, you lost all the guarantees there. Uh, I mean, not all, but a couple of them.
Yeah.
But anyway, like for example, these two things here, they don't mean the same thing. I mean, they do. They produce the same stuff, but they're not necessarily the same. This gives the impression it's a step process.
This is very
This
little.
is
Could you
exactly.
increase that?
Oh, it is. So here,
Nice.
here's the issue. When you write these, this was supposed to be. It's not, but it was supposed to be declarative. And
Yeah.
it kind of is, if you think about it. It's somewhat declarative. It's not really, but it could be better, but it kind of is. When you come up with this is not declarative whatsoever. It's a step by step process that you are describing. Now, it just so happens that this particular example has all the same stuff, right? It's just rearranging stuff. But I should not need to worry with this structure. And then I think they came up with pipes, right? I'm not sure if it's actually this thing,
Yeah, I don't
but they
remember
came up
which
with
one did it though.
pipes. And like this kind of stuff here is very silly. Anyway, let's go
Yeah, but
back
I
here.
hate doing the SQL way of doing that with the with.
Yeah, it is not very good. I gotta agree with that. So anyway, like SQL is a bad candidate to be the flagship of the theory, right? And people often mistake SQL with relational. Like they are not the same thing. But people often go at relational and they already assume SQL. That's why you have things like NoSQL. Like what the heck is NoSQL? That I already told the story, but just for the audience. When CJ Date, so is the story, okay? Not sure. When CJ Date learned about the name NoSQL, he was like extremely excited because it was like, oh, finally we're getting rid of SQL. That's like a bad language. And then he saw what it was, and he was like, oh man, we are we're back to like pre-SQL days,
It's
and that's
even
not good.
worse.
It's worse. Somehow it's worse. And then you just cry, right? What do you do at that point?
Yeah, but
So
that
anyway,
was date you said date, right?
yeah.
I think that was date misunderstanding the intent of what people
Yes,
mean by
exactly.
NoSQL.
Yeah, he
Uh,
expected like people
like
to get rid of SQL
yeah,
and actually do something
he
relational.
understood as like there were people that were knowledgeable and understood what SQL did wrong and are trying to fix it by naming it NoSQL. But that was not what happened there.
That's not what happened. So anyway, so modern relational databases, they are partially relational. So Postgres is a good example. It is not fully relational, but it's partial. Uh, They are internally inconsistent. They have different data models that go at odds with each other. They're logically under constrained. So you have problems to enforce constraints that should be trivial in a multi-group, namely mutual exclusion, right? How do you enforce mutual exclusion with two tables in SQL? You need to make a trigger or some other juggling, right, to make that happen. And that should be a very trivial constraint on a multi-group. And they are, well, semantically impoverished, right? I don't need to go over that. I already ranted enough. So anyway, and with that, we have things like data independence, right? So, which is the very first problem that we had back in the 60s, 70s, right? We're writing structures in a disk, and we want that structure to be independent from however the way I'm retrieving it. I should not by any means be concerned with how the data is stored. It should be stored as efficiently as possible, but I shouldn't have to care on the application side how that is stored. I should just find the right like the BMS should find the right technique to retrieve the data and give me. That's basically the idea. Anyway, uh, I'll just go over very quick. So actually, let me go over the examples first, and then I'll go over this. So let me start a new buffer here, and I'll go very briefly. So I went over these things here, and I want to, yeah. So let's see. So let's start with this. SQL is not a true relational data sublanguage. So what does that mean? Well, that means a couple things. That it is not a relational data sublanguage. It should operate only on relations. And what I mean only is that I mean only on relations, right? Not on other things. I mean, it may have other attributes like filtering, right? You need the predicate, but that's something else. But they should operate on relations and spit relations out of them, right? So that's one thing they should do. They should take relations as input and produce as output. They should be closed under relational operations, and they should be free of side effects and ordering. Those are the main things. Oh, and also they should have clear homomorphism with relational algebra. So select pi, sigma, and where, right? So these operations, it should be the same. Actually, the opposite, but you got the idea. So a couple of things. Like if I do this, assume two relations, employee and department. So that's the classical thingy, right? So imagine those two tables exist here. So if I do select, oops, if I can type correctly, select dept ID from employee. So if I do this, do I have any guarantee that I will not get anything duplicated? Because think, there are multiple employees with the same department number, right? So what? It will show you multiple repeated fields, like duplicates. Now, SQL added distinct, but it doesn't do that by default. So that's already a violation of a relational constraint. A true relational sublanguage, this should be enough for you to only have one department number or the unique department numbers, right? I shouldn't need to specify with distinct. So that's the first. I'll leave it here in case anybody wants it in the end. Another thing is like if I do a search, let's suppose I do this, where I want name from the employee, where the imp ID equals 10. Like what happens if this employee doesn't exist? Well, you're gonna get null, right? You're gonna get actually nothing. But then if you try to use it, you're gonna get null, right? So there is the operator exists atop of this thing, and then that will give you true or false, right? But the fact that you should return null here, like that this is equivalent, like empty is equivalent to null, is not really the same thing. So I could do things like, imagine you have a uh, let me think, a subquery, right? So select again, uh, and then you do from, and then you would need this as X, and then uh, here you try to do something like display this as this, right? So it's a select within a select. If this doesn't exist, oops, sorry. If this doesn't exist, the result will be null, right? So null, what does that mean? Does that mean that we're talking about unknown? We're talking about false? We're talking about what? So it's like, uh, basically your logic is dubious now, right? You don't know what the null actually. Uh, Tables are not relations. I'm tired of mentioning that. Uh, so relations, they don't have order. Tuples, they have no identity, essentially. Uh, Attributes, they are named, but they are not positioned. So there's like a bunch of other problems with the first topic already in SQL. The fact that it mixes, this is more interesting, the fact that it mixes declarative segments with procedural structure. What do I mean with that? Think of a relational algebra. I would have pi, uh, department name, and then I would have another thing here. So department. I'll put it in caps so we don't mix things. So department name, and then I'll do a natural join. So that is like it's like a bow tie operator, okay? Uh, with an imp thingy. So you have pi. So pi is basically give me the projection of this guy here atop of this. So this would be like the select in SQL. And then you would have from, right? This guy here, which is another relation. So this bow tie is a natural type it, I think it's easier. So you would join on every field from every tuple that is equal on its attribute, which are columns in tables, right? Or attempted to be. So there's no notion of sequence, control flow, nor evaluation, right? It's just this. It's just operations. Now, in SQL, when you do things like the equivalent would be select, d, dept, name, and then you do from, dept as d, join, imp as e on e the id equals to dept id, and then we may do like where e empt id, I don't know, greater than 100, right? So something like that. Now these, the user, it must decide, like they must decide the join order, the predicate placement, the subquery nesting, and the grouping structure. And all these choices, they affect the meaning. So with nulls, like where nulls will show up, because if I'm doing like a left join, for example, then where will they show up, right? The order, I mean, if I have two other joins here, if I have other joins, right? Imagine these are different relations, okay? So if this yields nothing, then I'll have nothing, right? But then if I change the order, let's say, from this to there, then the order might get different. So the planner uh, tries to be smart and make the order not matter, but in reality, it still do, because that's how the language works, right? The like SQL, I don't want to shame too much because the planner, like the query planner, is actually very smart, and nowadays they're very good planners. I think DuckDB has one of the best planners around. That's what I heard from a guy that worked on Microsoft on the SQL Server. So the SQL Server engine is very good. I think IBM's engine is very amazing, but DuckDB is one of them that does a very good job at basically analyzing and converting this to actual relational algebra and trying to be smart about it. But anyway, like the notion of ordering is there in SQL. Uh, I think if you were complaining about ifs, Lemus, I had an issue once that was absurd. It was like I had a bunch of ifs here, so ABC, XYZ. So I had a bunch of like stuff like this. And then I was having an issue that I was trying to use XYZ here, and it was giving me like wildly incorrect results. And I was like, what the heck is happening? And then I noticed I just had to do this. I don't remember where I put it. Materialize. Something like this, which is a random obtuse query, a word for queries for like TTEs, right? That basically materializes these before proceeding with the evaluation of the rest. And that solved the problem. Like it was a recursion issue. Like, man, you should not
Yeah,
be able to like you see, like this is the kind of
yeah.
silly thing that you're not supposed to deal with, but you do. So anyway,
Okay,
uh,
and we also must explain why you should not have to care about it. The reason is because when you're doing declarative programming, you are not supposed to care how that is supposed to be done.
you're
That's the
supposed to
entire
explain what,
point.
not how, right?
Exactly. So it's the same. I like the book's example. It's the same with HTML. You don't know how the browser will render that, but you're not supposed to know. That's the point. Your
That's the
HTML
point.
document is supposed to be descriptive. How that's going to be converted to what you see on the screen in the browser, that's someone else's concern, not yours. The same goes for an EST. When you make an EST, it's the role of the compiler to know how to do things with it. But when you're creating one, you're not supposed to know that anyway. That's why you have a specification that you just follow. That's the power of declarative programming.
Like here's the thing though, like SQL does have this, but it does a good job. I want to emphasize that because people might get the wrong impression, right? I don't want I'm not here to trash what we have. I think this like using SQL instead of like some random trash like what's the RocksDB thing that it uses from Apache? Lucene, right? Instead of using trash like that, this is actually good. It's not bad. I mean, you need to know some cryptic stuff, like materialized on
Your
these because of the
criticism is that
behavior.
it could be a whole lot better.
It could be better, and I want to improve it. That's I'm just criticizing because I want to see improvements. I don't want to see like the SQL committee adding more permissive rules for handling nulls. That's not the way forward. Like I think of the latest SQL version, there was a polemics because they added more. They added confusing semantics for nulls, as if they weren't confusing already. And that was like, yeah. Anyway, so instead of doing that, you should be fixing like slowly uh, the confusion that is widespread on the format, right? Not just
Yeah,
introducing more. And anyway,
and people may say, yeah, but that will make people confused because they're used to something else. And you must say, yes, people have to re-educate themselves sometimes. That's part of life.
that's
You
part of
need to be
life.
open to the idea that what you learned was wrong. And
Like
here's the
I'll
sad part.
press. Yeah, go.
The sad part is that the market respects your decision because you are the customer of it. So if you're not open to it, the vendors will not do it.
That's true.
You must be open to it. Then they have incentive to fulfill your desire of learning something else.
Like here's the thing: we were doing Karata, right? And that's like a prologue for those not aware. So imagine these things as predicates, right? So ABC would be a predicate. I'll put the stuff. XYZ would be another. And this would basically be a query that uses these predicates, right? So in the case it's a joint, so it would be imp ID, and then it would get the, sorry, let's do department, and then it would want the department ID from it. Well, it has other stuff,
If
right?
that
But
has
you
other
don't care.
stuff, yeah.
So let's put like this. Yeah, I want the name, so let's put like this. I'll put depth name because, well, The employee may have its own name. So this would be like a join, right? Debt
Yes.
ID.
Yeah, the
It's
join is essentially what you're writing right now.
so. I mean, I will need to add this empty ID and etc. But employee, right?
And don't
But
forget
anyway,
forget the
that
question mark at the end.
yeah, true. Anyway, and then I would use ABC here somehow, right? I
Yeah,
don't care.
exactly.
XYZ. So this is actually relational because you're basically doing description of the thing, but you're not concerned with order. Like I can change this.
Yeah.
It doesn't
Um,
matter.
well, for Prolog specifically, it kind of does, but Prolog, yeah, Prolog has some weirdness around that. But if
Yeah.
you
Well,
do coding, which we are doing now, right, which is slightly different, the order actually doesn't matter. It's not
yeah.
supposed to matter.
My point is that the unification should be the same for these two cases, right? That's the
Yeah.
thing.
Yeah, exactly.
Like what I'm saying is that SQL will do that here. Well, I don't know. It might, right? It might do it. Uh, and notice there are no variables here, right? So that's already a good thing. It's already a step forward to be declarative. I mean, there are names and labels for things, but it's not really variables, right? Things that you mutate over time or substitute. It's just, well, I think it's more analogous to substitution, right? I said no substitution, but I am not doing things like let, x, blah, blah, right?
Yeah.
So it's already better in that regard. So anyway, let me just conclude. So right now, so what do I want to is like um, well make people curious is that right now there is a set of people working on something that actually uh, is attempting to do a recovery. I think most of this knowledge is actually lost. There's just a few of old people that are actively aware of the issues and at the theory level. And I don't see a lot of people on the practical level that are aware of these issues. So David McGovern, he's a guy that's working on the semantic relational data model, which is an attempt to embed again semantics into the relational data model. Uh, and he was one of the people that worked closely with COD back in the day. So before COD passed away, I think in the early 2000s, uh, McGovern was one of the people that actively talked to him, and I think he has a good grasp on what COD intended with the relational model. COD, before his passing, by the way, he came up with this data. Uh, I mean, I expanded RDM. Was that it? Wiki. Ah, come on. I'm not gonna find it now, but anyway, there's a paper called worked on back in the when he did a conference in Tasmania, Australia, where he basically went over different extensions for the relational model. He made a couple of mistakes that he realized later on. Like, for example, normalization following a step, right? A step procedure. It's not a step by step procedure, like first normal form, second normal form. That doesn't exist. Second, he made a couple of mistakes on the operation, like when he designed the joins. I think that was one of the things I was talking with Pascal. Joins, they should not just group relations and return a single relation with them, right? Because then you lose semantics because you don't know why that join exists and you lost constraints in the process, right? So joins, the way they are not relational. They should return other multiple relations, possibly. So anyway, there's a couple of issues, right, with the implementation. I I don't have just have access to a draft that he published on his website about the motivation, but it was never finished. So anyway, let's pray he does. So anyway, those are the tenets that he's trying to go at. So if you have any interests, Google his name, you'll probably find. Um, so conclusion for today. There's a bunch more to go over, but I think it's already too big. So there's no RDBMSs today because the relational model failed essentially, and it's not because of theory, but because we failed to convey how it should be implemented in the first place. So the industry never understood it. SQL, basically from the get go, it was already non relational. The market, and when I say market, I mean there was a, it's not just the market, right? It was the government too. The fact that the government made, like, the government made Unix a standard back in the 90s, right? Like Apple had to do a Macintosh version, the AEX, because they wanted deals with the government, right? That was using Unix. Was using was Unix the best abstraction? That's debatable, but it it was the case, right? The government mandated it, or desired it, and then the industry followed because contracts with the government are good. Uh, so the standardization later on canonized such errors. So adding up these a bunch of historical accidents that still had the chance to be removed, they got basically set in stone as soon as we had a standard for SQL. And then education erased the whole distinction between the theory and the education and the implementation over the years. Like, just a tiny anecdote. When I learned about databases in college, it was actually quite decent. You see relational algebra, you do a couple of things, but you're much more concerned about the mechanisms, like trying to learn about the Arias algorithm, instead of trying to actually understand what the conceptual model means and what are the implications of this on storage. Uh, so basically, those things are just afterthought. You see.
Another
So anyway,
anecdote,
yeah.
I also had database, relational database in college, and there was a separation. At the time, I didn't know that because I was not smart enough. But now that I look back at it, I can actually see that there was a differentiation between the theory and the implementation, but they could have done a much better job on the theory part
They
because
could.
it was essentially a bunch of drawings, if I'm honest.
Mhm.
I didn't look. I didn't actually was taught. I was not taught the operators and the math behind it and all that stuff, which I think it was
Uh,
a mistake. But
Let me add one thing here. So I think the saddest part of it all, of these tragic events on like education, is that people get educated on the wrong things also. So for example, which is fair. Like professors, they also learn with the industry, right? So I remember like studying on how to do like phantom deletes, right? So the common practice for people is to just have a column that deletes things marking as a bool, right? So you don't want to lose data, which is fair, right? These boxes that we store information, they happen somehow, for some reason, from some historical accident, they happen to be mutable. So we lose information if we delete it. Fair. So what people do is that instead of the normal fact retraction that was supposed to be correct, like you are retracting a fact from the database because it's no longer true, no longer representing something that is true in the world anymore. But that doesn't mean deletion, like erasing it, right? So what people do is that they put a column. That's wrong, and then that makes the queries lower because you need to do things to compensate it. You need to add an index there, but it's an index on a bool. That's kind of silly. Uh, then you need to do queries based on cryptic wheres, looking at specific columns to see, oh, when this column is null and this other thing is 10, and this other thing is an enum of this kind, then this is a customer. I had to deal with systems that were, the queries were stupidly, like they were just in someone's head. I I remember vividly. There was a table with 120 columns. I remember how many? 122, by the way, because I counted. 122 columns. Most of them were nullable and full of GUIDs everywhere, like WE IDs, right? And then I had to do a query because we were getting mixed up customers of one kind with customers of another kind. And then I asked like the guy that designed that in the beginning, that was on a company for 10 years. And then I asked how, like how do I distinguish both? And then he said, oh, I think it's if you go to this column and then if it's null and you go to this other column and if it's greater than 10, it's a customer of this kind. And I was like, what the heck am I encoding here? Like, this is actually a query that you do. And then at that point, memory usage goes high. You need to start using a lot of indexes. Uh, your queries mean nothing, right? They don't bear any semantic on like any meaning on
And
the
the
queries
human memory
whatsoever.
usage is high.
Yes, exactly. Like the institutional knowledge is lost, right? If he got like, let's suppose that that guy he was there for like 10 years. What if he wasn't? What would I do? You see?
Yeah.
So like these systems are just like huge black boxes today, completely unmaintainable, made by generations of programmers that didn't know anything of what they were doing, and they were just like, oh yes, I'll just add a column here and put null, and that's it. So anyway, like that's just a rant in disguise of a conclusion. Uh, but I think that was important. Like I think I need to convey the frustration that these things and the lack of compliance with the actual theory causes on people. That's it.
Yeah. Okay, anybody has anything else before I finish the recording? Any questions, any comments? That, well, you want to be made public?
Windows NT was on POSIX certified. Yeah, because there's no way to run, right? You need to comply with whatever sells. So I don't blame them.
Okay, I am stopping the recording now then.